Hello everyone, welcome to another video. In this video, I will talk about a project which is going to overcome a particular problem that you might see when you're working in a company as a cloud engineer or as a DevOps engineer or even as a site reliability engineer. So in this solution or in this project, I will be using the AWS Lambda, which is the serverless service in AWS. I'll be using a Terraform to deploy the entire solution, and I will be using EC2 service as well, and I'll be using another service called EventBridge, and you will also see some Python code as well. Okay, so I'll start from scratch. So let's talk about a particular problem that you might see. In this case, you can say that it's going to be a real world production problem. So suppose you are working for a company. The company name is XYZ, and you have two EC2 instances. See here, I've taken the example of two EC2 instances, but it can be any number of EC2 instances. So you have two EC2 instances which are used by the developers for testing and QA activities, and these instances are required only during business hours, but they continue to run 24 by 7, including nights and even the weekends. As a result, of course, your entire AWS bill is going to rise. So your company pays for the compute resources even when no one is using them. Now, the cloud engineering team has been asked to automate this process so that these EC2 instances can be automatically stopped every Friday at 8 p.m. IST. Okay, I'm talking about IST because I'm working from India, but it can be any time. It doesn't matter. So you can change it to your time zone. Now, so the EC2 instances have to be stopped automatically every Friday at 8 p.m. IST, and these same EC2 instances have to be automatically started as well on Monday 8 a.m. IST. Okay, so we want to automate this entire solution. We don't want any manual intervention, and this solution should be reliable, repeatable, and managed as infrastructure as code IAC. So we do not have to follow all the steps manually from the UI or from the CLI also. We want to automate this. So we want to have some code that we can keep in a repo that can be used multiple times in the future. So for this, we'll be using Terraform. So the proposed solution is to solve this problem, we are going to build a fully automated serverless solution using AWS services and Terraform. And this is going to be the architecture of the solution. So we are going to create two EventBridge schedule rules in the service called EventBridge in AWS. This service is going to use AWS Lambda service. And within Lambda, we will have a Python code that will be using Boto 3, which is the AWS SDK for Python, okay, which is used to make your Python code interact with AWS, basically AWS APIs. So this event bridge schedule rules are going to use this AWS Lambda function. Within the Lambda function, you're going to have the Python code plus a Boto 3, and it's going to be used to start and stop instances on a schedule. Okay, so this is going to be a simple architecture of this entire solution. So the technologies used are Terraform, AWS Lambda. I'll be using Python 3.12 runtime environment inside my Lambda function. I'll be using Boto 3, which is AWS SDK for Python. I will be using Amazon EventBridge. I'll be using certain roles and policies that will be assumed by my Lambda function to do what it's supposed to do. And at the end, we're going to start and stop EC2 instances on a schedule. And whatever activities or whatever events are happening inside our Lambda function, we'll be able to see all that in the monitoring tab of our Lambda function in the form of CloudWatch logs. So this is the entire solution. So if I talk about the solution workflow, so we are going to provision all the resources via Terraform, and EventBridge is going to run on a predefined schedule that will always that will be defined inside our Terraform code only. EventBridge is going to invoke the AWS Lambda function. So basically, you see, we will have two EventBridge schedules, one for stopping the instance and the other for starting the instances. So if I just show you the instances also, so these two are going to be the instances. Let me name it as app server 2. So we have two app servers here, application servers that we want to stop and start on a schedule. So right now these are in start running status. So we want to stop them and we want to start them as well. So we'll test the solution. Okay, so EventBridge, which is the this service that is going to invoke our Lambda function. So basically, this is the service that is going to invoke the Lambda function to stop the instance and to start the instance also. Okay, so Lambda is going to read the requested action, whether it's a start or a stop. We will see how to configure that. And using Boto3, Lambda is going to call the EC2's APIs, and the specified EC2 instances will be either stopped or started automatically. And CloudWatch logs is going to capture every execution for monitoring and troubleshooting. So some of the benefits, like why do you want to do it? Okay, so as I mentioned, it's going to reduce our AWS infrastructure costs. It's going to eliminate any repetitive manual work because it's going to be completely automated. So it's going to improve your operational efficiency, and you're using the serverless architecture with minimal maintenance. Okay, and also you're trying to manage all the infrastructure via Terraform, and we will be following infrastructure as code best practices here. So the outcome is, at the end of this project, the EC2 instances will automatically stop every Friday evening and start again every Monday morning after we are able to successfully deploy this automation solution. Okay, which is going to help reduce unnecessary AWS costs while requiring zero manual effort. So this is the entire story of our solution. Okay, I mean our problem statement and our solution that we want to use to overcome the problem. Okay, now I'll talk about the code itself. So this video will be slightly longer because I want to explain these things in much more detail. Okay, as you see like elsewhere. So I'm going to talk about everything in much more detail so that you are able to understand it to that level. So I'll talk about this Lambda function also. So this is going to be the main code that is going to run inside our Lambda function. So if I go to my Lambda function also, so this is my Lambda function. So this has been already deployed via Terraform, but I'll just show you how it was done. Okay, so if you go to code here, so this is where you can find the code. So this is the code that I'm trying to explain. So this code is already here, and whatever files you see here, it will be pushed to a GitHub repo, so you will be able to access it. So you will be able to clone the repo and you will be able to try the solution on your own also. So let's talk about this entire code. So I'm using two Python libraries, OS and Boto3. So OS is actually used to read values from the environment variables that are passed. Okay, so in this case, our Lambda function is going to have environment variables. If you go to environment variables, you can see there are two instance IDs here. Okay, so to read these values, okay, so this code, it needs OS, which is to read the environment variable values. So if you see here, I'm saying import OS, and then I want to import Boto3, which is AWS SDK for Python, which is used to interact with our AWS APIs basically. Okay, so now I'm defining another thing called EC2 is equal to Boto3.client EC2. So I'm trying to create a connection here with the EC2 service using Boto3. So here I'm saying that use Boto3 to create a connection with EC2 service. And then I'm defining a function. So remember, in Lambda functions, you will always be defining one function, and by default, it will be called handler. So this is our Lambda underscore handler function that we're defining inside our Lambda function. So the Lambda handler, it has two things, event and context. So the event is going to contain the data that will be sent to the Lambda function when it is triggered. In our project, it is going to be coming from EventBridge. So EventBridge is going to send action start or action stop through the event. And if I talk about the context, so the context is going to contain the information about our current Lambda execution, such as the function name or request ID and any remaining execution time. So we're not using context in this project, okay, but we define it like this. Then if you see here IDs, so I'm saying that read the values from the environment variables using OS, and then split the instance IDs with IDs using the comma. Okay, as you can see here, because the instant IDs right now they're written like this, and these two have been separated by a comma here. So I'm saying you have to split this entire value into two parts. So this is one value and this is another value, the meaning of this line. And then I'm saying action is equal to event dot get action, and get the action, whatever it is, the action, it can be either start or it can be stop. As you can see here, action is equal to event dot get action. It means that get the action. Okay, so this will depend on the type of trigger that we have, because we have two schedule rules in EventBridge. So it can either be start or it can be stop. So I'm saying if the action is start, then you have to run EC2 API call, which is start instances. And what instances you have to start? All the IDs that you were able to split here. So I'm saying instance ID is equal to IDs, which means that you have to start instances. You have to start all the instances which were here. Okay, so instance IDs is equal to IDs. As you can see here, IDs. So this is for start action. Else if action is equal to stop. If it is not start, then it would be stop. If it is stop, then you have to stop the instances. Once again, the instances are going to be the same. So this is the way we are able to stop the instances and we are able to start the instances also. So both the conditions are covered here. Okay, and then I'm saying return status, action, and instance. So this is going to be our output basically of this entire code. So I'm saying return, what you have to return, status as okay, the action performed, and the instance IDs in the output. So this is the entire Python code. It's a pretty simple code, but it's always important to understand each line, what does it mean. Okay, so this is our Lambda function code. Now I'll move on to backend.config. So in this example, what I'll be doing, I'll be using this parameter called backend config, and generally it is used when you're working for a company. This is because this config can be different for different environments. So you would want to use a backend config parameter like this, so that whenever you are initializing your Terraform, you're using a specific backend configuration for your Terraform project. Okay, so if you see here backend.config, all I'm saying is I'm going to use an S3 bucket. The name of the bucket is this one, tf state file org 098712334. As you can see here, this bucket is already there in my account. And by the way, I'm using EU West 1 for this project. As you can see, I'm using EU West 1, this one, Ireland. So in the Ireland region, I have this bucket already. So I'm saying use this bucket. Within the bucket, you have to use this folder, Lambda EC2 scheduler, and store the file terraform.tf state here. And I'm using region EU West 1. And I want to encrypt all the data of this S3 bucket for security reasons. Okay. Then I'll talk about data.tf. I'm using this data block to create an archive file. So in Lambda function, what happens whenever you are using any code, you generally use a zip file. Okay, so you are able to zip your entire code and then you can upload it to your Lambda function. So this is how we use Lambda function in general. So what I'm trying to do here is I'm saying you need to archive a file. Okay, and it's going to be lambda underscore zip. So the type of the file is going to be zip. The source file, I'm saying from where the files need to be picked. So I'm saying be in the present working directory. So this is the directory where I'll be running my Terraform code. So it is represented by path.module here. So this is going to be my current directory where I'm running my Terraform code from. So in my present directory, go to lambda directory. As you can see, go to lambda directory, you will find a file called lambda underscore function.py. So you have to zip it. Okay, so once again I'm saying be in the same directory, in the same folder, and create another file called lambda.zip. Okay, so here I'm trying to create lambda.zip here. Next, I'll go to main.tf. Okay, so this is where our main resources are going to be created. So these are the resources. You see all the resource blocks in Terraform, which is used to create resources. So the first resource I'm trying to create, I will start with an AWS IAM role, which will be assumed by my Lambda function. So I'm going to use AWS IAM role resource. This is going to be the name which will be referred by my Terraform code. The name of the actual resource, the actual IAM role in AWS is going to be this one, var.project underscore name hyphen lambda hyphen role. So var.project underscore name you can see in the variable section. Okay, so project, sorry, this is not variables. So in the variable section, you can see a project underscore name. The value are going to come from a tfvars file. Okay, so let's come to tfvars. So these are the values which are environment specific. Here I'm using dev.tfvars, but it can be any environment. It can be qa.tfvars, it can be prod.tfvars, it can be staging.tfvars. It depends. In this example, I'm just saying that these are the dev instances because these are used by developers. So the value of project underscore name is going to be EC2 hyphen scheduler. So this is going to be the name in AWS that will be given to the IAM role hyphen lambda hyphen role. Okay. So here I'm saying the trusted entity or the trusted service, you can say it's going to be lambda here. So it is how you represent the service, which is going to be which is going to be trusted by this role. So it's going to be lambda.amazonaws.com. Action is going to be STS assume role, and the effect is going to be allow. Okay, so this is your trust policy of the role. Okay, and then I'm saying in the next resource block, this is where I'm trying to create my IAM policy. Okay, so this is going to be the main permissions policy or the main permissions that will be given to your lambda function while it assumes this lambda underscore role. Okay, so here I'm saying effect allow action because I want my lambda function to invoke and start and stop EC2 instances. So you need EC2 start instances and EC2 stop instances, and you also need EC2 describe instances. Here I'm using resource star. With EC2 describe instances, you have to use star only. Okay, so you don't have any other option if you include this. So okay, so it's all right because we're using describe instances, so we can use this. We don't have any other option here. Then in the second permissions, I'm saying effect allow actions logs create log group, create log stream, and put log events as well. So this is used by Lambda to put its to create its log events and log stream and put it to your log group in CloudWatch. Okay, so this is for that. Then I'm talking about my main resource, which is going to be my Lambda function. So I'm saying I want to create a Lambda function called scheduler. Okay, but in AWS, the name is going to be var.project underscore name hyphen scheduler. Okay, so this value will be coming from dev.tfrs. Then in this function, I can use a role. So I'm going to use the same role that I'm trying to create here. So I'm saying AWS IAM role dot lambda underscore role dot arn, which will be coming from this block. Then handler, as I mentioned, each lambda function, it needs a handler. So handler, you can say it's like an entry point. It's like the main processing block that this lambda is going to execute. Okay, so handler is important. So here I'm using the default lambda handler. It's called lambda underscore function dot lambda underscore handler. And this entire code, it runs really well on Python 3.12. So that's going to be my runtime environment here. Then I'm saying the file name, which means that which file you're going to upload. So as I mentioned, our main code or our main, you can say the logic here is going to reside in a zip file, which is going to be lambda underscore zip. So so this is what I'm referring from the data block. As you can see here, data block, archive underscore file, lambda underscore zip, and here you have the output underscore path. So same path I'm referencing here as well. Okay, this one, data.archive underscore file dot lambda underscore zip dot output underscore path. I'm using another property here, source code hash data.archive underscore file dot lambda underscore zip dot output underscore base 64 sha 256. So this is actually used whenever you make any changes to your code. For example, you make any changes to your code and you re-upload your zip file. So any changes that is being made, it's going to be automatically detected by Terraform and it will be applied the next time when you run Terraform apply automatically if you include this. So this is just for that. And I'm saying I also want to create environment variables. If you see our Lambda function, it is using environment variables. It is using instance IDs. So instance IDs are going to be picked from environment variables. Okay. So this is where the environment variables are going to come from. So inside my Lambda function, I'm saying I want to create an environment variable and it's going to be instance IDs, and I want to join the instance IDs. Okay, so the instance IDs are going to come from var.instance underscore IDs, which is going to be my variable here. As you can see, it's going to be a list. Okay, and the values are going to come from dev.tfrs, this one. So these are going to be my environment variables. Okay, as you already seen, because I already like deploy the solution, but I wanted to explain this as well. Okay, so here you can see environment variables. So this is going to be instance IDs in our case. So let's go to main.tf again. So these are going to be my environment variables used. Then, as I mentioned, we need two rules here. Okay, the first one to stop the instance, because our instance is in start status right now, which is our use case here. So you can see the instances are running. We want to stop them first on Friday evening, and we want to start them again on Monday morning. So here I'm trying to create two event bridge rules. So AWS event bridge, you can create uh, these multiple rules. So I'm saying I want to create the first rule to stop my EC2 instances. So this is going to be the name of this event bridge schedule rule, and here I'm using this cron expression. So this is how it's going to identify when to stop the instance. So I'm using this cron expression here. This is always defined in UTC time zone. So just ensure that like whatever time you are choosing, you are converting into UTC time zone. Okay, so this is what is taken here by default. Okay, in this case. So similarly, I create one for stop, another one I'm going to create for start. So this is going to be the schedule to start the instances. So this is where you can again use a UTC based time zone. So like whatever time you are using, you need to convert it to UTC here. Okay, and then I'm saying, so I defined two rules, one for stop, one for start. Now here I'm saying I want to set a target in these rules. So the first rule, which was for stop, there I'm defining a target to invoke, right? So in this case, it's going to be our lambda function, and we can use the same lambda function for both the rules here. So all I'm saying is this AWS Event Bridge stop rule is going to use our CloudWatch, sorry, our lambda function as a target. So here I'm defining that the ARN is going to be a lambda function. Okay, the same lambda function that we have created in this configuration only. So we are trying to reference that, and I'm saying that you have to pass one a payload. So this is actually called the payload, and here I'm using actions equal to stop. This is going to be passed as adjacent to this stop event. So basically, I'm saying that I mean I want to use a lambda function here as a target of this schedule event, which is this stop event, and I want to pass stop action. Okay, I want to pass stop action, which means that it's going to stop the EC2 instances. Similarly, I'm doing it for start also. So once again, for the start rule, I'm using the same target lambda function, and this time the lambda function is going to start the instances. So as you know that our lambda function has both the logic. If you see the code here, so it has both action, start and stop. So same we are saying here as well, that for stop rule and pass the action is equal to stop as the payload, and for start pass the action is equal to start. So these two Terraform resources, they grant a permission to our Amazon Event Bridge to invoke the Lambda function. So one permission is to stop the schedule, and other one is to start the schedule. Without these permissions, Event Bridge would not be able to trigger the Lambda function. So that is why these are here. Okay. So this is about main.tf file. Dev.tf files, we already know that we're using AWS region called EU West 1, name of the project. It can be anything. I'm using EC2-scheduler. Environment is equal to dev, and these two are the instance IDs which we want to stop and start on a schedule. Then locals.tf, we already know. These are used to tag our resources, and we don't have to define it again and again. We just define it once, and we just reference them everywhere, wherever we want to add some tags to our resources, the common tags. Okay. Then outputs.tf is going to be the name of the lambda function after generation. Then provider.tf, here I'm defining just the region that I'm going to use for my AWS provider. Okay. And variables.tf I've already defined. So this is the entire code. Okay. I've tried my best to explain each and every line that I see here, okay, in the code, so that you are able to understand it well. Okay, now this is done. Now I'm going to initiate my Terraform. So as I mentioned, we are going to use this backend config file. So let's do Terraform init backend config backend.config. One more thing, guys, I already have access to my AWS account from this terminal here. So since I'm on my home laptop, I'm using AWS access keys of a user. But in production, or you can say in company where you're working, even in the dev account or in the QA account, you will be using some sort of single sign-on to do that. Okay, so so in this case it's going to be access keys, but when you're working for a company it's going to be via SSO. So you interact with your AWS account via CLI using some SSO like CLI SSO, or there are some other tools as well. Okay, so I just want to clarify that also. So let's try to initiate the Terraform code. So you can see a Terraform is initializing. So you can see my Terraform has been successfully initialized. Okay, this is the first command, and next I'm going to do Terraform plan. And once again, I'm going to use a Terraform plan, and I'm going to pass this var file, because as I mentioned, we use the same code for multiple environments, okay, in multiple AWS accounts. So we always want to use that. So we always provide the environment specific files in a TFVars file. So in this case, I'm saying I'm using it in the dev account, but you can create a similar file for any other account. You just need to change the values, and the same code can be used in multiple AWS accounts and in multiple AWS environments also. Okay, so this is going to be the command to create the plan for us. So we will see what's going to happen. Just one more thing, let me just come out of it. Okay, so before I run a Terraform plan, let me just change the values, because I want to change the schedule. So let's go to main.tf here, and you can see the schedule here. So I want to show you how to stop the instances. So right now instances are in are in running status. So what I'll do is, so the current time here is 10:32 p.m. I need to convert the time as I mentioned. So let's go here. So let's do 10:36 p.m. IST to UTC. So it's going to be 5:06 p.m. UTC. Okay, so I'm going to do that. So let's do 5:06. So let's do 5:06. Maybe I'll do 7, and that's it. And same I'm going to do for the start also. So I'm going to stop the instances, and then I'm going to start also automatically using this solution. So let's do 11. Okay, so 10:36. So we have 3 minutes to do. So let's do that. So it's going to generate the plan. So you can see a 2 to change, because I'm changing the time, as you can see here. So let's run this quickly, because the time we need to run it before the time passes. So I'm going to do Terraform apply with the same wire file, and I'm going to do auto approve also, so that we can save some time. The apply was done. Okay, so we still have like 30 seconds or so. So instances are in running status, but it will soon be stopped. So we'll just wait for a few seconds now before the event bridge is going to invoke a Lambda function to stop the instances. So you can see after a few seconds, the instances are in stopping status. So this is all happening automatically via our solution. So the instances are stopping, and as you can see in the code, just after 3 minutes, so 17:10 and 17:13, after 3 minutes, the instances will be automatically started also. So we'll see that part also. So I'll just pause the video here and come back after 2 minutes when our instances are going to be automatically started as well. So you can see the time is about to be 10:43. Okay, so now if you just hit refresh, after a few seconds we will see the instances will be automatically started as well. So you see the instances have come to pending status. So when you start the instance, it will always come to pending, and then it will go to running status. So the solution is working absolutely fine. Okay, so we are able to automatically stop the instance, as well as we are able to start the instance also. So this is my Lambda function. If you go to monitor, and if you just filter out the logs for the last 10 minutes maybe, so you can go to custom, choose the last 10 minutes, maybe 15 minutes, apply, and you can see that it was invoked at 10:40. Okay, so at 10:40 it was invoked. Okay, after some time you will see another invocation. Okay, it takes a little bit of time to reflect here. So this is for the starting or stopping of the instances. Similarly, you will see for stopping of the instances also. You can see one more invocation at 22:43, which was for stopping, which was for starting of the instance. Okay, so these two other invocations, one at 22:40 and another one is at 22:43. So this proves that this lambda function was actually invoked, and we can see in the configuration in the code that it is configured to run. If you go to its configuration, if you go to its triggers here, so this is the clone expression that I was talking about. So this is going to be the trigger of your lambda function. So there are two triggers, one for stopping of the instance, another one for the starting of the instance. Okay. So this is how you can build a solution, and I've tried my best to explain each and every bit of it so that in the interview, if you're saying that you have developed this type of automation solution using Lambda, Python, Boto 3, EventBridge, EC2, so you should be able to explain everything, like what was the exact solution and how did you deploy it, and what was the code which was used. So all those things I've tried my best to explain it to you. Okay, so this is the entire solution. I hope you liked the video.
And before I go, I would like to talk about my YouTube membership program where I have a lot of premium videos available. As you can see right now, I'm talking about a production Docker file. So this is a sample Docker file from a production environment, which I'm covering here, and I'm explaining each and every instruction that is there in this Docker file. Apart from that, I also have videos on some of the most important site reliability engineering terms that are often asked in the interview. How do you explain that? I have video on SRE golden signals, which is very critical when you're actually working and you're configuring some dashboards for a particular application. So you would need SRE golden signals. And then I have a hands-on project on SLI, SLO, SLA. So I start with the theory, like how do you explain these terms and how do you explain an end-to-end project that you've done on SLI, SLO, SLA. So that I've covered here. Here you can see I'm using a Java Spring Boot application, which is being monitored using Prometheus and Grafana tools. And the application is deployed into AWS EKS clusters. Apart from that, I also have video on distributed tracing with Grafana Tempo, and I also have one video on how do you use open telemetry for metrics collection for a Java Spring Boot application in Prometheus and Grafana. So it's again, all these videos are hands-on, which means that I'm going to share the document, the end-to-end document that I'm following here, and how do you configure all these things in real. So all that I'm trying to cover here. Apart from that, I also have video on logs aggregation using Grafana Loki tool for Java Spring Boot application. So how do you aggregate logs from multiple applications into Grafana Loki? So that I am covering here. Then in production, we don't use the standard Prometheus to collect our data. We use an enterprise solution which is called Mimir. So the difference between Prometheus and Mimir I've covered in this video. I also have a shell scripting crash course with production scenarios where I'm going to talk about the type of questions that are asked in the interview. Apart from that, all the fundamentals of shell scripting that you should learn for the interview. Then I have other videos as well. As I mentioned, I have multiple videos on Prometheus and Grafana based Java Spring Boot application monitoring in production, how it is done. So these are the videos. Apart from that, I also have Terraform, I have Kubernetes, and I have AWS, Linux, and you can see some of the videos in my YouTube membership program are actually recordings from my real live batches that I've run for SI trainings. A lot of people have got the job as well. So I have these recordings as it is, and in each of these videos I'm talking about how it's going to look like when you're actually working in real as an SRE. So I'm talking about all that. Yeah, so these are the things that I have on my channel, so you can take a look at it. If you find it useful, you can go for the membership as well. It's going to immensely help you in your interviews. All right, so that's all I wanted to cover in this video. I hope this video was useful to you. If it was, please hit the like button. Please share this with others. Please do subscribe to my channel and keep watching my channel. All right, guys, that's all for this one, and I'm going to see you in the next one. Bye for now.